Hempcrete is now the American Building Code, Appendix BL of the 2024 International Residential Code, adopted in 49 of 50 states. That's a real milestone. It took years. And if you read the first sentence the code uses to describe the material, you find a word that quietly demolishes about half of what you've been told about hempcrete. The word is nonstructural. Not strong, not load-bearing, not a concrete replacement. Non-structural. Here's what that actually means, and the two other ways that this material fails. And then, at the end, why I'd still build with it anyway. Because all three of these failures are real, and all three of them are the wrong reason not to use it. Failure 1. It cannot hold anything up. Hempcrete's compressive strength lands somewhere around 0.5 to 1.5 megapascals, depending on the mix. Concrete is in the range of 20 to 30. So call it roughly 1/20th the strength in the same sentence as the word concrete. The building code doesn't hedge on this. Appendix BL approves hemp lime as a non-structural wall infill system. Full stop. It cannot be a foundation. It cannot go below grade. It cannot carry a roof or a floor or a second story. Which means if you build a hempcrete house, you are not building a hempcrete house. You are building a timber frame house or a steel frame house, and then you are packing hempcrete into the gaps. You still pay for the frame, you still pay for the engineering, you still pay for every structural member you are going to buy anyway. Hempcrete is not replacing your walls, it's replacing your insulation, and the entire structural system underneath it is still on the invoice. Nobody selling hempcrete leads with that sentence. Failure 2. It dries in weeks, not days. Concrete cures in about 28 days, and you can walk on it long before that. Cast in place hempcrete and sprayed hempcrete generally need something like 4 to 8 weeks before you can put finishes on the wall. Full cure can stretch to 8, 10, 12 weeks depending on thickness, climate, and humidity. Because hempcrete doesn't set, it dries, and then it carbonates slowly, pulling carbon dioxide out of the air as the lime hardens. That's a beautiful process. It's also a scheduling problem. On a job site, the calendar is the budget. Every week the wall sits there drying is a week of financing, of insurance, of a crew you can't schedule, of a trade that can't start. And you cannot rush it. If you seal a wet hempcrete wall with an impermeable finish, you have trapped moisture inside an organic material. We'll get to what happens then. Here's the part nobody explains. The failure has a fix, and the fix is boring. Hempcrete blocks. Cast and cured in a factory, they arrive dry. There is no on-site cure time at all. Blocks cost more per unit, and they will save you a month. If somebody tells you hempcrete is too slow, ask them whether they priced the blocks. Most of the time, they didn't. Failure 3, water. This is the real one. The first two are inconvenient. This one is destructive. Hempcrete is highly porous. That porosity is the whole point. It's why the wall breathes, why it buffers humidity, why the R value works. But porosity has a cost. Hempcrete has a large moisture storage capacity, and it wicks. Water moves through it vertically and horizontally. In the Hurd, the woody core of the hemp stalk that makes up the bulk of the material is organic. It is plant matter. The lime binder is highly alkaline, and that alkalinity is genuinely protective. It resists mold. It resists pests. This is why hempcrete has a reputation for durability, and the reputation is largely deserved. But under prolonged exposure to moisture, the Hurd can degrade. This is research where hempcrete samples were cycled through immersion, freezing, and drying over and over. The porosity of the material increased as the microstructure changed, and the compressive strength went down. So did the thermal performance. The wall was still standing. It was just getting worse. That's the failure mode that should scare you, not a collapse. A slow decline inside a wall where you can't see it. And this is why the detailing is not optional. A hempcrete wall requires a proper roof overhang. It requires a rain screen or a vapor permeable render. It requires a foundation that lifts it off the ground. It requires a finish that lets it breathe. Get the detailing right and Hempcrete walls last. There are hemp-lined buildings in France that have stood for decades. Get the detailing wrong and you have built a very expensive sponge. So, 3 failures. It can't carry load, it's slow, and water degrades it. Now here's the part I actually want you to hear. Every one of those criticisms is a criticism of Hempcrete as concrete. And Hempcrete was never concrete. Stop comparing it to concrete. Compare it to the thing it actually replaces. Fiberglass batt insulation. Against fiberglass, Hempcrete is fire resistant. Fiberglass is not. Against fiberglass, it has thermal mass. It doesn't just resist heat flow, it stores and releases it, which flattens out the temperature swings in a building in a way that an R value on a spec sheet does not capture. Against fiberglass, it buffers humidity instead of trapping it. It breathes. It doesn't need a plastic vapor barrier stapled across it. Against fiberglass, it doesn't off gas. It resists pests, and it sequesters carbon in the wall for the life of the building instead of emitting it during manufacture. Roughly R2 per inch, that's the number people use to dismiss it, because fiberglass is about R3. And in a 12-inch wall, R2 per inch is R24. In a monolithic assembly with no thermal bridging, no gaps, no settling, and no seams. Hempcrete's biggest problem is not its strength, or its cure time, or its porosity. Hempcrete's biggest problem is its name. The word concrete promised something structural. The material is never going to deliver that, and the building code says so in its opening sentence. Call it hemp lime, call it hemp insulation. Compare it to the pink stuff in your attic instead of the gray stuff in your foundation. And suddenly, every one of those 3 failures is just a speck. Next video, I'm going after the number nobody in this industry will publish. What fiber hemp actually pays per acre against corn and soy. Because if the walls are going to get built, somebody has to grow the stock.